Hi there. In this lesson, we're going to compare hypothesis testing with confidence intervals. So now that we've been reviewing both of these, we get to put it all together. So I'm really excited about that. And so that's what we'll do in this video. In this whole lesson, we'll also explore a few different topics that come up, like error types and power and determining a significance level. Okay, so let's jump into how are confidence intervals and hypothesis tests similar and different? Okay. Whoops, I just found a typo, so I'm going to fix that. Hypothesis test to test our hypotheses. Okay, so first of all, there's abbreviations, which you may have seen already. I'm going to sometimes use HT for hypothesis test and CI for confidence interval because they're kind of a mouthful to say. Okay, I'm actually going to go one at a time here, kind of go row by row in this table here. So on the left, we have confidence intervals. On the right, we have hypothesis tests. So first of all, what is it? A confidence interval determines a range of plausible values, right? That's why we have that range from a lower bound to an upper bound, written in parentheses. Okay, it's a range of plausible values for a parameter, right? So the parameter is something we want to know about the population, right? Okay, so we want to know something about the population. We want to know a parameter. We take a sample, then we estimate that parameter, okay? Right, so it's an estimate. And we've seen on the GeoGebra calculator that they use the word estimates for all the confidence intervals. Okay, now a hypothesis test is a little different. It determines statistical significance, right? It's really a yes or no. It's significant or it's not. Yes or no. And it's the thing that they have in common is they're both based on a sample. Okay. Great. So they also tell us something a little bit different. So the confidence interval determines the size of the effect. So the size of the effect. You could think of that as the width. Like we might have a really narrow interval or we might have a really wide interval. So the size of the effect is what kind of range can we expect? Okay. The hypothesis test, on the other hand, determines the strength of evidence, okay? And the strength of evidence is against the null. Or we also sometimes say for the claim or for the alternate, but it's really against the null because we're assuming the null is true. Okay, so if we have a small p-value, and the smaller the p-value, the stronger the evidence, right? Small p-value gives evidence. Okay, so we can talk about the strength of the evidence, but it's still a yes, no, reject the null or fail to reject the null, right? Okay, another thing we could compare is the fact that a confidence interval is always two-sided, right? It always has this lower and upper bound, so it's always two-sided. And we have a confidence level C, so like 95%, that's the middle 95% of the area. So we're talking about a central area. Okay. A hypothesis test can be one or two-tailed, right? So it can be one-sided or two-sided. In this case, we use a significance level alpha, which we compare with the p-value. Okay, so we have a few different things. We're going to compare in one of these videos, compare C with alpha. Okay. Another really important part, and I'm going to show you this on a graph in a moment, is understanding where each one is centered. And if you can understand that and just keep that in mind, I think that really goes a long way. So a confidence interval is always centered at p hat, right? The formula is always p hat plus or minus, and then we have our margin of error, which is that whole formula, but it's always p hat plus or minus. That's the part I want to emphasize. It's always centered at p hat, right? We get our sample, that's always going to be the middle of our graph. So when we're doing different simulations, it can be really helpful to remember that. The standard error also uses p hat in the calculation. So when we have our z star times the square root p hat q hat over n, we use the p hat there. Right, and that makes sense because when we do a confidence interval, all we have is that one sample. So we take our sample, we've got our p hat, we have our n. That's literally all we have to go on. So that's what we use. Now, a hypothesis test, on the other hand, we have a couple things because we also have a p hat from a sample, but we're assuming the null is true. So the hypothesis test will be centered at p0. Okay, so I'm going to write down, we're assuming the null is true. So that's why we use p0, which is the null value, whatever that number is in our hypothesis, okay, hypotheses. And because we're using p0, that is also what we use in the standard error. And so we use that when we're checking the conditions. Same for over here, we use p hat when we're checking the conditions. Here we use p0. And that is in our test statistic formula uses a p0, the square root of p naught q naught over n. Okay, so I hope that's helpful to kind of get a little overview of how these relate to each other. Now let's do a visual comparison. Okay, so first I'm going to start with a one-tail test, and then I have a two-tail test down below. Okay, so on this graph, I'm going to put our, I'm going to make this our hypothesis test. So this is our null value, p0. Okay, so I'm going to say for a hypothesis test, here's our null value, okay, and we're assuming the null is true. So when we simulate or when we are using the normal distribution, either one, this null value is right in the center, okay. Then we also, after we make our hypotheses, we get a sample, and so we have a p hat, which is somewhere. I'm just going to assume it's over in the right tail for this, just as an example. We have a p hat, and then this, I'm going to shade in this area, that is our p value, right? This area from p hat towards the tail, and if it's a one tail, so this would be a right tail test, that is our p value essentially, okay? So that's the chance of getting the observed result or toward the tail. Whoops. Sorry, my hand wasn't quite working very well right there. Let me make sure you can see this. The p-value is the chance of getting the observed result or toward the tail. If we've seen with probability in the normal curve, if we just put a single value, we're going to get a probability of 0 because it's just a vertical line. There's no width to it to have an area. And also, anything further away is also evidence against the null. Okay, so we also count anything towards the tail, anything away from the null value. Okay. Sometimes you also hear the words or more extreme, right? That's another way of saying or towards the tail. Okay, but we're always looking at the tails in our p-value. Okay, and then we compare that with alpha. That's the hypothesis test. We compare that p-value with alpha, determine if it's significant or not. Okay, so let me put in now a confidence interval with this, okay? So the confidence interval is centered at p hat. Okay, so let's say, and I'll keep this in green to keep this, I'm going to draw it again, p hat. Let's say our confidence interval goes all the way over here. It's going to be the same width on both sides, because p hat is in the center. Based on our standard error of p hat when we do our formula, and we get a lower bound and our upper bound, okay? Now, if this stretches all the way and includes the null value, then that is evidence for the null, right? So we would fail to reject. Okay, so if I'm going to write P0 in the interval supports the null. Okay, so then, sorry, I need to move this up a little bit. Supports the null, so then we would fail to reject. Okay, so isn't that interesting how these compare with each other? I really like seeing this visual, maybe because I'm a visual learner. But this p hat, this interval will be somewhere here, but also maybe it doesn't include p naught. So I'm going to do that example in the next one. Okay, let me just make sure I wrote everything I wanted to on here. Yes, okay, great. So now let's look at a two-tail test. Let's compare this with a two-tail test, and then I have some text down below that will reiterate this. Okay, so same idea with the hypothesis test. This is P0. For our hypothesis test, we're setting up everything assuming the null is true, but now we have a two-tail test. So our p hat would be either one of these, right? We don't know. It just depends which way it comes up. I will draw it on this side for variation. Okay, so let's say our p hat comes up below the null value, and so our test statistic would be negative. Over here our test statistic would be positive. Okay, and then we form our confidence interval. This time I'm just going to make it a little bit smaller so that it does not include the null value. Okay, so when the null value is not in the interval, that supports the claim. That supports rejecting the null. Okay. Now, one thing I want to say, let me write that out first, and then I do want to mention something for a two-tail test. So first let me write out P0 not in the interval supports the claim or the alternate. Now, in this case with a two-tail, we don't have to worry about the direction because it's either an in or out. But in a one-tail, we do need to make sure the interval goes in the correct direction. Okay, so let's say, for example, we have to make sure it's in the right direction. So I have an example of this coming up. It's not quite clicking with me right now how to draw it on here. But let me just write supports the claim. Okay, I've actually got it typed out right here. So let me talk about that. So if the null value P0 falls within the confidence interval, so that's the first case we did, that supports the null hypothesis and we fail to reject the null. Okay, that one's the easier case for a one-tail as well, because it's just, if it's inside, then that supports the null. Now, if the interval does not contain the null value, this is the part I was wanting to demonstrate, and the interval is in the direction of the claim, that is evidence against the null hypothesis, and we reject the null. Okay, what do I mean by that? So it's possible that the interval is going in the wrong way. I think it's unlikely, especially looking at my drawing here. I think it's unlikely, but it's possible. So let me show you that. I have an example of that on the next page. So let me grab that page here, and I'll show you what this looks like. Okay, I gotta get my pages aligned here. Okay, so let me move this up, keep this on, and move this up here. Okay, so in this example, we're going to use the lesson 3 confidence interval that we've already done for the true proportion of U.S. teens who supported parental consent for social media. We're going to test the hypothesis that fewer than 50% of teens are in favor of parental support. Okay, so I'm going to do this using these things we've already made, and then we also will do a simulation. That was our p-hat that we had from that published study. So let's write out our hypotheses. The null value, test the hypothesis that fewer than 50% of teens. So our null value is going to be 50% or 0.50. So the null H naught P equals 0.5, and HA, the alternate, P is less than 0.5. Okay. And then we have our interval already. So if we were going to do a test using this interval, we would see we already got 0.4341 to 0.4584. Okay. So then we see, where is the null value? Okay. Is the null value in the interval or out of the interval? Okay. Well, it's not, this does not include the null value. So in fact, our 0.50 is all the way above it. So the interval is all the way below. It's completely below. And that is the direction of our claim, right? It is less than. Okay, so we would, in this case, reject the null. So that's what I mean by, and the interval is in the direction of the claim. Okay? So because this is a left tail test, if the interval was all completely above 50%, 50% wouldn't be in it, but it would be going in the wrong direction. Okay, so in that case, our evidence is just in the wrong direction, and so it's pretty clear that it's not evidence for the claim, but I just want to make sure that we're checking that it's going in the right direction. Okay, so that means is the interval, change colors. The interval gives evidence for the claim because it is completely below the null value. Okay, and if I were doing a full problem on this, I would put it in context, but right now I'm just trying to isolate this particular part of the interval being on the correct side or not. Okay, so now let's do our simulation of this same situation. And so essentially we're going to do the hypothesis test with a simulation. So we're going to run a simulated hypothesis test with a significance level of 0.05 and see whether it agrees. Okay, so if we were just using the interval, we would reject the null. Let's see what happens and find our simulated p-value. So let me switch over here. Okay, good. I've got stat key already, and we're looking at hypothesis test in the right, and we're doing a single proportion. So I'm going to click on test for single proportion. We need to put it in our null, but happens to be the default in this case of 50%. So that is already changed for us. Now I need to edit data, so I need to put in our p-hat of 668 and 1453. Hit enter. I can double check that right over here, and I have my proportion of 46. That was from that article, 46%. Okay, so generate my 2,000 samples, and this is a left tail test. We wanted to know if it's less than half, less than 50%. Okay, great. Now I need to find the evidence for p hat. All right, so I need to put p hat down here of 0.46 or 460. Then once I do that, then the upper value, this area, is the p-value, so 0.0015. So a very small p-value, right? So based on this method, we would also reject the null hypothesis. Okay, so let me write this down. Back over here. So our p-value, yours might be a little bit different. I think that's right. 001, is that what I got? 0015. Where's my notes? 0015. Okay, remember yours might be slightly different. That is less than 0.05, which we're using our alpha level here. So we would also reject the null. In this case, the two methods agree, okay? They don't always. Oh, I'm so almost out of space. Okay, they don't always agree. So if you ever come to a point where they're not agreeing in a homework problem or quiz problem, that's a good reason to double check, okay? But it is possible, don't doubt yourself too much, it is possible that they don't agree, okay? So it does happen sometimes, but it is like a little bit rare, okay? So more often they will agree, okay? So just so you're aware, if they don't agree, just double check. If they do agree, might also be good to double check. It's always good to double check, but more often they agree than not, okay? The reason they might disagree sometimes is because we have different standard errors. So remember how I said the standard error on the confidence interval is p hat. The standard error for the hypothesis test is based on the null value. So the standard errors give us slightly different widths, and they might be slightly different. Okay. Okay, great. I hope that was helpful to see how those relate to each other, and I'll see you in the next video.